Multiplying radicals have a different condition than adding or subtracting radicals, which we would expect because multiplication is a different operation than addition or subtraction are. So it's important to make sure that you compare and contrast what the criteria are in order to continue on with simplifying with addition, subtraction, as opposed to what the criteria is for continuing on with multiplication. Now, to multiply radicals, we would need to make sure that they have the same index. But when we're multiplying radicals, we don't need them to have the same index as well as radicand like we did with adding or subtracting radicals. They just have to have the same index when we're multiplying. Now, if they do have the same index, the way we carry out the multiplication of the individual radical expressions is that we have our nth root of A and our nth root of B, and if we're asked to multiply these together and they have the same index, here the index is n, then that's equal to the nth root of A times B. So let's look at our examples here. In our first one, it's the cubed root of 6 multiplied to the cubed root of 20. So I do have a multiplication, and the index of the first radical is 3, the index of the second radical is 3. So they have the same index. Both the 6 and the 20 are the radicands. So this is the cubed root of 6 times 20. Now I'm going to write it like that at first because I want to remember that when I want to leave my final result, I want to leave it in simplified form. And in order to see what can simplify out of the radicals, I want to go down to the prime factorization to see if I have the same number of identical factors as the index, and that would allow me to simplify that portion of it. So while I could multiply these together and get the cubed root of 120, I would then take 120 off to the side to do its prime factorization. Well, one of my first steps of factoring 120 would possibly be to go 6 times 20 and then continue on from there. So I'm going to take advantage of the fact this is attached by times and carry out my prime factorization from there, all inside the radical, because these numbers are manageable enough that I don't need to go off and do a prime factor tree. We can probably talk it through just by looking at the factors. So our first factor, 6, is not prime, but its prime factors are 2 times 3. So I'll write 2 times 3, and then times. 20 is not prime. It factors as 4 times 5, but 4 can still go as 2 times 2. So 20's prime factorization is 2 times 2 times 5. So if you wanted to write that out, you could, but we just spoke through the process. Now this is all attached by multiplication under the cube root. So if I have 3 identical factors under the cube root, that number can come out of the cube root. So I have 2 times 2 times 2. I have 3 factors of 2. So a 2 will come out. But I only have 1 factor of 3 and 1 factor of 5 under the radical. They have to stay under the cube root. And I'll just go ahead and multiply those back together. So 3 times 5 is a 15 under the cube root. So my answer in simplified form of my multiplication for this first problem is 2 times the cube root of 15. Now again, make sure that if you have cube roots in the original problem, and if not everything came out, that when you write the portion that's still the irrational piece of this answer, you write the 3 is in the crook of the radical sign as the index to show that it's 2 times the cube root of 15. Okay, next up, I just have another way of showing multiplication, and I notice the 4 is attached to the cube root of 7 as multiplication, and the negative 2 is attached to the cube root of 98 times multiplication. So it's multiplication between the parentheses, and it's multiplication inside the first set as well as the second set, and I don't have any outside exponents. So since there aren't any pluses or minuses between terms in these parentheses, it's all attached by multiplication. We can use the commutative property of multiplication to multiply the numbers that are factors outside of the radicals together. So 4 times negative 2 is a negative 8. And then the radicals do have the same index, so I write that as the cubed root of 7 times my 98. Now again, I want to leave this in simplified form when I'm finally done, so I'd like to take this all the way down to its prime factorization inside the radical to see if anything can simplify. So I'll carry down the -8, and I have my cube root. 7 is prime, so I'll write 7 down. 98, let's think about that. 98 is even. It's 2 times 49. 2 is prime. 49 is 7 times 7, or 7's prime and 7's prime. So 98 gets replaced with 2 times 7 times 7. Now, under a cube root, I need 3 identical factors if I'm going to be able to bring that number out. I have 3 identical factors of 7, so I can bring a 7 out, and it comes out and multiplies to the factor that's already in front. So -8 times 7 is a -56 times the cubed root of 2. For the simplified form of that answer. Okay, last question is to take 5 times the square root of 2 and multiply it to 3 times the square root of 6. Again, this is all multiplication, so since it's all multiplication in each of the attachments, I can use the commutative property of multiplication to rearrange the factors, and so I multiply the outside numbers to the outside numbers. 3 times 5 is 15. The square root of 2 times the square root of 6, the index match. If the index isn't showing, it's assumed to be a square root. So I have the square root of 6 times the square root of 2 is the square root of, and I'll go my 2 times 6. 6 I want to factor down to its prime factorization. This is 15 times the square root of 2 times 6 factors, that's 2 times 3. And under a square root, I just need 2 identical factors to free that value up. So I have 2 2's, that brings out a factor of 2, but not enough 3's, that stays under. So 2 times 15 is 30 times the square root of 3. And that's the simplified form of this multiplication. So there we have 3 different examples of multiplying radical expressions where I just have a monomial times a monomial idea, just a one-term radical expression times a one-term radical expression, and writing them in their final simplified form.